Hi, in this video I'm going to talk about the Doomsday argument, a pleasant diversion for students of probability theory. First, some disclaimers. I didn't make this up. It's a published scientific argument. You can look on the internet. There's an article on Doomsday argument in Wikipedia, and you'll find that the argument was first proposed by Brendan Carter in 1983, and a subsequent paper by J. Richard Gott, which is quite famous. You can find the paper reprinted on the internet as well. This argument is closely related to the anthropic principle, which is one of the arguments used in favor of the multiverse hypothesis. I refined some aspects of the argument, and let's see. The idea is to calculate the survival probability of the human race. So specifically the question is, what's the probability that the human race will survive another n years without major calamity or extinction? And to compute this, we only need some basic principles of probability theory. So I'm going to talk about uniform random sampling. Now, if you have a set of individuals A, and if an individual is selected from that set in such a way that no characteristic or property of that individual is preferred, then any individual from A has equal probability of being selected. This is a common principle used in surveys or in gambling. For example, suppose you put names in a hat, shake them up, and draw one. Now, you haven't used any characteristic or property of any individual to make that choice. So, in fact, any individual has the same probability of being selected. No one is preferred. All right, second principle. If the individuals in the set A are listed in some order, then the probability that the selected individual is in the first percent of the list, first X percent of the list, is X over 100. Individuals in the first X percent of the list, probability is X over 100. Well, let's see what I'm talking about here. Let's list the individuals in order. See if my pen works. Okay. Starting from the first individual and going on. So let me just list them in order like this. Okay, so these are the individuals in A. Okay, and let's make a marker. So there's the first one. We'll say the last one is out here. Okay, and we'll make a marker here. And we'll suppose that this is X percent of the total. Now, if that's X percent, of course, this is 100 minus X percent. Now, if I make a random sample, if I select an individual randomly, what's the probability that the individual will be to the left of my dividing line? Well, the proportion of this left-hand side compared to the entire population is X over 100, X over 100, because X is in percent. Okay? So the probability that the person is on this left-hand side is simply X over 100, because that's the proportion. Okay? Now, I'm not trying to pull the wool over your eyes. This is certainly an accepted principle in probability and statistics. Right now, you are a random sample. By virtue of the fact that you are reading or hearing this argument, you've been selected. Now, what set have you been selected from? There's no distinguishing characteristic used in this selection other than that you've been exposed to the Doomsday argument. No one's used your name or address or sex or age or any other information except the fact that you've been selected. The fact that you're reading this is predicated on the fact that you are exposed to the Doomsday argument. So what does that mean? Let A be the set of all individuals, past, present, and future, who have been or will be exposed to the Doomsday argument. Now, as far as being exposed to the Doomsday argument, you're no different from anybody else. You have no distinguishing characteristic, so you are a random individual selected from this set. Okay, so remember the picture of all the individuals selected. All right, now we have the first one. We have all the individuals. These are all the individuals who've been exposed to the Doomsday argument, and you are one of these. Now, so far, we don't know how far out this goes, but you are one individual in this list. There certainly is a first one, and you can list them one by one in order of exposure. Okay, so let's compute the probability. So again, you are a random sample from A, where A is the set of all humans who have been or will be exposed to the Doomsday argument. So let's list the individuals in A in order of exposure. So that was the picture I drew at the bottom of the previous slide. The probability that you are in the first X% is X over 100. That's the principle of uniform sampling that I showed before. The probability that you're not in the first X% is 1 minus X over 100. That's simply the complementary probability. That's accepted notion of probability theory. Okay, so the probability you're not in the first X% is 1 minus X over 100. Okay, so let's do the numbers. There's a 50% chance that you're not in the first 50% of people exposed to the Doomsday argument. In this case, if people keep getting exposed to the Doomsday argument at the same rate as they have since 1983, then the human race can only go on as it has been for at most 33 years. Let's draw the picture to make that clear. All right, so the Doomsday argument was formulated in 1983. And since that time, people have been exposed. So I'm going to list them in order of exposure. And you are here. Right now, there's a 50% chance that you're not in the first 50%. What does it mean that you're not in the first 50%? It means the 50th percentile took place somewhere here, before you. And you have the first 50th percentile over here, last 50 percentile, that last 50% over here. So that means that this time interval here, from 1983 to the 50th percentile, is less than 33 years. Now, if the first 50% is within 33 years, and the rate of exposure is the same, then the second 50% should also be less than 33. So what does that mean? That means certainly this interval here is less than 33. So we're less than 33 years until the end. Okay? We can't continue on, so this picture can't continue on like this for more than 33 years. Before 33 years are up, something must happen. The rate of exposure must go down drastically, either through calamity or extinction. So, just to reinforce that, there's only a 50% chance that the human race will escape a major calamity or extinction within the next 33 years. Now, I did this with 50%. We could do it with other percentages. You can draw the picture and convince yourself that there's a 75% chance that you're not in the first 25%. Okay, by the same argument, the first 25%, if that's 33 years, then the remaining 75% would be 100 years. Okay, it means that there's a 75% chance that the human race will experience major calamity or extinction within the next 100 years. Right, now there's possible objection to this. I'm assuming that people are being exposed to the Doomsday argument at a constant rate. But since knowledge and education are improving, it's much more reasonable to expect that people will be exposed to the Doomsday argument faster than before now. So from 1983 until now, people have been exposed, maybe not so much. But now we have the internet and we have widespread education. We're going to have more people exposed to the Doomsday argument. People are going to get exposed faster. Now, the answer to this objection is that you've just made things worse. For example, say 10 million have been exposed since 1983. So that means the first 50% is before now, and the next 10 million should be exposed in less than 33 years. So that means there's a 50% chance of calamity in less than 33 years. Okay, so the conclusion: don't share this video with your friends. The more people see it, the more people will be exposed to the doomsday argument. The faster the second 50% will happen, and the faster the condition will be fulfilled, and shorten the time that we expect the remaining lifetime of the human race. Okay, so it will only hasten the destruction. So think about that, and have a nice day.